Chapter 2 is talking about absolute value. This lesson we're going to be talking about solving absolute value equations. What an absolute value equation is something in which an absolute value is equal to a number, and we are solving for a variable involved with it. What is absolute value? Absolute value is when we're measuring the distance from an object. We're worried about the distance, not the direction. And when we're solving an equation, we have to consider the fact that there could be multiple directions we could go. So let's look at this. If we know that there is an object that's 5 units away, that's what this 5 is standing for, it could be where x is standing at positive 5. And we're talking about being 5 units away from 0. There's nothing else inside it, so we know it's 5 units away from 0. So we could be over here at positive 5 on the number line. Or, because that's 5 units there. Or we could be 5 units the other direction and be at negative 5. So positive 5 or negative 5. And we'll separate our solutions with commas when we actually write it in the computer system. So let's look at a little bit more complicated problem. Still, we have absolute value is equal to a number. We know that what is inside that absolute value is either equal to that positive 5 or what's inside is equal to a negative 5. So we have two equations we have to solve. What's nice is they are very similar in solving. We're going to add 1 to each side, and we end up with 2x is equal to 6. Divide by 2. And x is equal to 3. Or in our other scenario, I like to draw a little line between it so my work does not overshadow each other. If I am, instead of that positive 5 away, I was at negative 5, I'm going to add 1 here and add 1 here. This time I have negative 5 plus 1, which gives me a negative 4. My 2x is equal to negative 4. And when I divide by that 2, I now have x is equal to negative 2. So I know I could be at one of those two locations. I don't know which one. And so both of them are my solution. We typically list the smaller value first, which in this case is negative 2, comma, our larger value, 3. And it's not that that's an ordered pair, it's just that we're listing the terms. It's just like if you have a list of things that are correct, just put in a comma between them. But we could make it a little bit more complicated. And this looks scary, but what if I said that's all that, I'm just going to represent that with all the absolute value. I'm just going to put a smiley face in that spot. 3 smiley faces minus 1 is equal to 8. You could solve this just like you've been solving any other one. We would add 1 to both sides, and we'd end up with 3 smiley faces are equal to 8, or equal to 9, excuse me, because 8 plus 1 is 9. And then divide by 3. And so that will leave us with that smiley face is equal to 3. Well, that smiley face was just my way of representing that x plus 2. And now we're back to that same problem we had before. And so I am going to erase this, and I'm just bringing this information that we found here. I'm just going to bring that information up. We know that absolute value of x plus 2 is equal to 3 based upon that work I showed over here on the side. But so I can show all my work over here, I'm going to erase this, and we're going to figure out what that x plus 2 could be, or what the x could be. So what is inside my absolute value could either be a 3, because if I have a 3 and I take the absolute value of 3, it comes out as 3. Or what's inside the absolute value could be a negative 3, because if I take the absolute value of negative 3, I end up with 3. So I know that inside material could either be one of those two numbers. And so I'm just going to work the positive 3 first. Negative, subtract 2 from both sides. X is equal to 1. Or if I subtract 2 from both sides, x would equal negative 5. And again, we're with those two solutions. We either have x equals 1 or x equals negative 5. And putting them in order, we have negative 5, 1. Those are our two solutions. So this one was just a little bit more complicated in the fact that we had other things around that absolute value on the outside. And when you have that, you first solve for that absolute value, and then you solve the inside material. Figure out what it could be. Because absolute value, again, you're just looking at that has to be 3 units away. Now the last and the most most complicated form is when the outside material, when you solve for that outside material, there is a variable there. And if that is the case, we have to watch for solutions that will solve and look true, but when I check it, it doesn't work. And I'll show you what that means as we go through it. So we have this absolute value already by itself on one side. And so that means that my meat of that absolute value, that 3x plus 2, must equal either a positive 4x plus 5 or it must equal a negative 4x plus 5. And what I mean by that is we have a negative of that whole side. So we have to worry about distributing that negative sign. We're not going to touch that side yet. We're going to start over here on the positive side. And so if I need to solve this, I need to get my x's on the same side. Choosing one side or the other, I'm just going to move my x's to the left. Minus 4x, minus 4x. Some of you may solve this in shorter steps. I am just going to show every step on separate lines. And that gives me a negative x plus 2 is equal to, those cancel, 5. Now I'm going to get my 2 on the same side as the 5. And I've got to keep this balanced, so I'm doing it to the same on both sides. Negative 1x is equal to 3. Dividing by that negative 1. A positive 3 divided by negative 1 is and negative 3. Now let's look at my other side. And I am going to have to distribute that negative sign through to both terms. So I end up with a 3x plus 2 is equal to a negative times a positive 4x is a negative 4x, and negative times a positive 5 is a negative 5, and plus a negative gives me a minus. Now I want my x's on the same side, and so I'm going to go ahead and move my x's, just like on the previous problem, over to the left. And so if I have a negative 4x, to cancel it out, I would need to add 4x, because negative 4x plus 4x is 0. And that's my goal there, is to cancel it out, get a 0. So that gives me 7x plus 2 is equal to a negative 5. Now I've got to move my 2 over to that side with that negative 5. And so that gives me 7x, that positive 2 and that minus 2 cancel out, equals negative 7. Divide both sides by 7, and x is equal to negative 1. And so it appears at this step that I have two solutions. And we could end up with two solutions. But let's go ahead, and I want to go on to the next slide and just check that work and see if those both work in. So what I'm going to do is I'm going to take that original equation, which is 3 times my x plus 2, all of that with the absolute value bar around it, is equal to 4 times my x plus 5. And so the two numbers I am checking out is the first one, we ended up with a negative 3. And so I am going to put a negative 3 on both sides. And that's just checking out that first solution we had here. And so if I do negative 3, over on my right-hand side, I'm just going to work my right-hand side all the way down until I get a number. And then I'll go back and work my left-hand side. And so on my right-hand side, I had 4 times a negative 3, negative 12, plus 5. And that gives me a negative 7. And basically on this, I am checking to see if this is going to equal. So I don't really know if those are equal on both sides. But let's see what happens on the left-hand side. And so I have 3 times a negative 3, which is negative 9, plus 2. But remember, I have absolute value bars around that. Negative 9 plus 2, that gives me a negative 7. But I've still got to take the absolute value of negative 7. And so the absolute value of negative 7 is a positive 7. That does not equal. And so when that happens, when it solves to give us a number, but when we check it, it doesn't equal, it's called extraneous. Let's see if the other one is extraneous as well. And if they both are, that means we have a no solution on this. There is no way for this to work. And that is possible to be a no solution. So let's find out. The other side, we had a positive, or excuse me, a negative 1 as what x was. So on this side, we're checking that -1. And so I'm going to put it in my equation. I'm going to go ahead and just do the right-hand side first again. And I'm just checking to see if that will work. +4 times -1 gives me a -4 plus 5. And a -4 plus 5 is 1. Well, that's at least more hopeful, because if that's a +1, I can actually get an absolute value that the result is going to be positive. So that's good. Let's check out this other side. 3 times a -1 is a -3 plus that 2, but we're going to take that absolute value of whatever we get there. So that means we're going to take and figure out how far away it is from 0. Not worried about the direction when we're looking at the number line. So we have a -1, and I take the absolute value of -1, and that answer is 1. So that does check out. And so that means that that is a solution. So this one works. So we end up with one solution and one extraneous. So that means the other one does not work. The only one that works is x equals -1.